Hi guys, this is the 2.3 notes. This is factored form of a quadratic function. Okay, so um, what we are doing is factoring and then using factoring to solve equations and things like that. Okay, so hopefully you remember factoring from algebra 1. Okay, so right, we're looking for to factor into two binomials. So something like x plus m times x plus n, right? And that comes from that standard form, right? X squared plus, and then our middle term or our b comes from m plus n, and then our c term, right, comes from m times n. Okay, so this is kind of how we're trying to break it down. Okay, so, right, if we look at this problem here, right, 7 is equal to whatever m plus n is equal to. And 12 is equal to what they're when they're multiplied together. Okay, so in order to find out what m and m are, we want to find out what two numbers multiply to 12 and add to 7. Okay, so want to find what two numbers multiply to 12, because that's what our C is, and also add up to 7. Okay, so two factors of 12 that add to 7. Okay, so first we want to list the factors of 12. So find the factors of 12. All right, so factors of 12 would be 1 times 12, 2 times 6, 3 times 4. And also we have the negatives, -1 times -12, because it gives you a positive, right? -2 times -6, and -3 times -4. Oop. But, right, we should know that we have a positive 7 for our sum that we're trying to find. So obviously, if we add two negative numbers together, we're not going to get a positive, right? So none of these are going to work, right? So we look at these. If we take 1 and add it to 12, do we get 7? No. 2 plus 6 is 8, so no. 3 plus 4, yes. Okay, so these are our m and our n, right? So we can say m and we can say n. That's because 3 plus 4 adds up to 7, and 3 times 4 equals 12. Okay, so, right, our m is 3 and our n is 4. So again, we have x plus m times x plus n. So when we factor this out, we get x plus 3 times x plus 4. And that is our solution. Okay. Obviously, you don't need to write all this. If you can kind of see it right off the bat, oh, I'm looking for numbers that multiply to 12. Okay. Something that's going to add to 7. You can kind of think of it in your head if you don't want to write down all the factors, right? You could think 2 and 6. Well, 2 plus 6 doesn't equal 7. So let's try another one. 3 times 4, 12, right? 3 plus 4, 7. Yes, it works. Okay, so factoring, honestly, the more you do it, the better you get at it. The easier you can kind of see and comprehend different things. Okay, now sometimes we do not have expressions with a coefficient of 1 for x squared. Okay, so they're much easier when your coefficient or your a term is just 1. Right, now when it's not 1, say like 2, it's going to be a little different. Okay, so um because it's 2, right, that means one of our coefficients of x is going to be 2. So one coefficient of x is 2, and one coefficient and 1 is 1, right? Because 2 times 1 gives you 2x squared, right? So that means we're looking for something with a 2x and an x, okay? Now, what we're going to do is we're going to guess and check factors of 3, well, so -3, right? Like before, we found factors of 12 in A, right? But we didn't have a coefficient different than 1 for x squared, so that's why we listed the factors and we kind of figured out. Right, this one is a guess and check, more or less. Right, so guess and check factors of -3 that will work, so that will make this work. Right, so the factor, let's list the factors of -3. Right, it's only 1 times -3 or -1 times 3. Right, so we think about it. Right, so we're gonna have to guess and check. Okay, so let's try the first one, +1 and -3. And to see if it works, we need to try the FOIL method. Okay, so FOIL method to check. Right, so when you FOIL it out and you multiply it, we should get back to this original expression. That's our objective. So we get 2 times x is 2x squared. 2x times -3, -6x. 1 times x is positive x, and then 1 times -3 is -3. So we get 2x squared minus 5x minus 3, which it works, right? This is the same expression we started with because it works. Our factored form is 2x plus 1 times x minus 3. Okay. All right, so I'm going to have you try these ones on your own. Then we'll go through them. So if you want to pause it now, we'll go through them after. All right, so here's the solutions to the try it on your own. Right, there's the factors of A. Right, our B is 0, right, because it's right. Our B is 0, so therefore we're looking for the factors of 9 that add up to 0, which is -3 plus 3. Right, therefore those are M and our N. Now for B, you got to find the factors of 2. Right, our coefficient is 3, so one has to be 3x, one has to be 1x, right, to get 3x squared. Okay, so we've tried the factors of 2, which is 1 times 2, or -1 times -2. Your B is a -7, so most likely you're going to use the negative numbers, right? You need to get to a negative B, right? So I would try -1 times -2, or -2 for your M and -1 for your N, right? And then test them out. I tried -1 and -2, and I FOILed them out, and it came out to the correct answer. Therefore, that is the correct factoring of this quadratic, 3x minus 1 times x minus 2. All right, for these problems, we're going to factor again, but what we're going to do is set them equal to 0 and solve. Okay, so what we're going to do is figure out which x's essentially are going to give us a solution of 0. Okay, so we're going to get them into binomials, and we're going to set the binomials, each binomial equal to 0, and solve for x. And this is how we solve equations by factoring. Okay, so our first step, though, is to get it in standard form. So we need to move the 42 to the other side. So x squared plus x minus 42 equals 0. Okay. And now we need to factor quadratic. Okay. So we're looking for factors of negative 42, right, that add to positive 1. So we're looking for numbers that are close to each other. So the factors of 42 that are close to each other would be like 7 and 6. So 7 times negative 6 or negative 7 times 6 we're going to look for. Right? Which one would add to positive x? Right? That would be positive 7 and negative 6. Okay, so those are going to be my factors. So x plus 7 times x minus 6 equals 0. Right? And you can think, if you really want to check it, right, you get x squared, and then you get negative 6x and positive 7x, which becomes positive 1x. And then negative 6 times positive 7 is negative 42. So we factored correctly. Now, right, set both. Right, these are binomials. Right, these are both binomials. We're going to set them both equal to 0 and solve for x, because we're looking for when you figure out which x makes this solution equal to 0, right? That is that's how we solve this. Okay, so x plus 7 equals 0, and x minus 6 equals 0. So you're going to see we're going to get two answers, right? So we get x equals negative 7 because we subtract the 7 over, and x equals positive 6. When you have a binomial like x plus 7 or x minus 6, your solution is always going to be positive. Right? X plus 7 becomes x equals negative 7, right? Because you're finding out which number makes that binomial go to 0. So if we plugged in negative 7 for x, right, it'd make that 0. Okay? And that'd make the whole function 0. So our solutions are x equals negative 7, comma 6. All right. So we're going to do the same thing for the next one, but again, our coefficient's not 1 for x squared. So we're going to have to work with that. But all right, we're going to move the 9x over, so we get positive 9x. Move the 5 over by subtracting it, so we get negative 5 equals 0. And we want to find two binomials, right? One's going to be 2x and one's going to be x. Right? And we want to think about the factors of negative 5. Right? That'd be negative 1 times 5 or 5 times negative 1. Right? We're looking for a positive 9. Right? So essentially we want the bigger number to be positive. Okay? So I would test 5 and negative 1 first. Okay? I'm going to do negative 1 here, positive 5 here, and then right, you can check to see if it works. All right, we get 2x squared. 2x plus times 5 is 10x. Negative 1 times x is minus x. Negative 1 times 5 is negative 5. So we get 2x squared plus 9x minus 5. So yes, it works. So now we bring down these binomials and set them equal to 0. So we get 2x minus 1 equals 0. And we get x plus 5 equals 0. Move the 1 over, we get 2x equals positive 1. Divide by 2, we get x equals 1/2. And then this one, right, we just add x equals negative 5. So our solutions are x equals 1/2, comma, negative 5. Right, and that's how we solve the equations by factoring if we do not have a coefficient of 1 for x squared. All right, so very similar to the first example, we're just setting our binomials that we found when factoring equal to 0 and getting a solution for x. Now I want you to try these on your own, and then I'll show you the answers and we'll go through them. All right, so here's the solutions, right? Get them in standard form. So A, we had to move the 20 over, so we get negative 20. The factors of negative 20 that add up to 8x, or sorry, positive 8 would be 10 and negative 2. So that's our m and n, and then we set them equal to 0, and we get a solution of x equals negative 10 and x equals 2. The next one, we need to move the 3x over by subtracting it, and the 2 by subtracting it and setting it equal to 0. The factors of negative 2 that make this work are 1 and negative 2, right? So 2x plus 1 times x minus 2. If we FOILed that back out and you tested it, we would get back to this original function here, right? So it does work. And then we set both binomials equal to 0. We get x equals negative 1/2 and x equals positive 2. All right, now we have a real world example. This is a multi-level driving range, has 3 levels. Marco hits golf balls from the second level, which is 32 feet high, right? So the height of the ball x seconds after Marco hits it is modeled by the function h of x equals negative 16x squared plus 16x plus 32. The ball will hit the ground after how many seconds? Okay, so in order to solve this, right, what we want to do is factor out this equation, right? But what you can do first is, since they all have a 16 in common, right, and we know it's easiest to factor a function when we have a positive one for our coefficient of x squared. Let's factor out negative 16 from the whole equation, right? So we get h of x equals, I'm going to take out negative 16 from all 3 terms. So I'm dividing this by negative 16, this by negative 16, and this by negative 16. So negative 16 divided by negative 16 gives us 1x squared, or just x squared. 16 divided by negative 16 gives me negative 1, so it would be negative x. So be careful on that. Make sure it's negative x because it's 16 divided by negative 16. And then 32 divided by negative 16 gives us negative 2. Right, and as you can see, this function here, right, is much easier factor than the negative 16x squared plus 16x plus 32. All right, so we want to factor this. All right, so factors of negative 2 are 1 times negative 2 or negative 1 times 2. All right, so which one adds to negative 1, which would be here, because we want to add it to our b, which is negative 1. All right, this adds to negative 1. So that's our m and our n. So we factor it. Negative 16 times x plus 1 times x minus 2. All right. Now we want to solve for them. So set equal to 0. So x plus 1 equals 0 and x minus 2 equals 0. We get x equals negative 1 and x equals 2. Right, now it says the ball will hit the ground after how many seconds? So if we think about our x-axis is the number of seconds. Right, we got 2 solutions, x equals negative 1 and x equals 2. Can we have negative seconds? No, we cannot. So technically, we're not going to use that negative 1, right? We can't have negative seconds. Okay, so our solution is going to be the positive solution, right? Which is 2. So the ball hits after 2 seconds. Right, and that's how we solve this. All right. The last example in this section, this is a long section, so is finding where our intervals are positive and where they're negative. So where they're above the x-axis, where they're below the x-axis. Okay, so right, we know from just looking at graphs that we change from positive to negative when we cross the x-axis, right? And that means it changes when we hit our x-intercepts, right? Because our x-intercepts are when our y is 0, right? So if you think about it, right, like just a random parabola, and here's your x-axis, right? It changes when you hit these x-intercepts, right? These are positive to the left of this. This is all negative, right? And this is positive to the right of that. Okay, so when you find your x-intercepts, then you're able to find where it's positive, where it changes to negative, and where it goes back to positive. And if it's concave down, right, it'd be the opposite, right? So your x-intercepts, right, it stays negative, right, all the way to negative infinity, and then all the way to positive infinity, right? But is positive between our two x-intercepts. Okay. So, right, how do we solve this? So what we're going to do is it says identify the intervals in which this is positive. Okay, so we're looking for when it's only positive. Okay, so what we want to do is solve for x. Okay, we want to solve when x is equal to 0 because we want to find those x-intercepts. Okay, so we're going to set x squared minus 2x minus 3 equal to 0. Right? We want to find when y is 0, right? And that's how we solve for x. So now we want to factor this out. Right? Factor. Right? So we get x and x. So we're looking for which factors of negative 3 add up to negative 2. Okay, so that'd be a negative 3 times positive 1. Right? Negative 3 plus 1 is negative 2. And negative 3 times 1, it gives you that negative 3. So your m and m are negative 3 and 1. Now, right, let's solve for them. So set them equal to 0. So x minus 3 equals 0. X plus 1 equals 0. We get x equals 3. X equals negative 1. So these are our two x-intercepts. And this is where function changes from negative to positive. Okay. Now, we want to look at when the function is, right, less than negative 1, between negative 1 and 3, and then greater than 3. Right, so x is less than negative 1. Right, x is between negative 1 and 3, and then x is greater than 3. Right, so now one way to kind of fast forward this is to figure out, so figure out if concave up or down. Right, so we want to look at our a. Our a is positive 1. Right, so it's positive, therefore it's concave up. So our function is going to look like this. Okay. Now, right, here's our x-intercepts. So this is x equals negative 1, x equals 3. And right here's our x-axis. So, right, anywhere greater than 3, it's going to be positive. Anything less than -1, it's going to be positive. And then anything between, it's going to be below that x-axis or negative. Okay, so, right, there's two ways to solve this. You can solve it this way, right? So this is type 1, right? Or we can test points that are less than -1. And if we get a positive solution, then it's positive. If we get a negative solution, it's negative. Okay. So I'll go through both ways. We just went through the first, right? The other way is to try an x less than -1. So we'll try -3. All right. And what I'm going to do is substitute it into this equation. And if it's positive, then we know our interval is positive for everything less than -1. If it's negative, then our interval is negative for everything less than -1. Okay. So we get y equals -3 squared minus 2 times 3 minus 3. So -3 squared is 9. -2 times 3 is -6. Right? And, oh, sorry, this should be a -3. So that's a positive 6. -2 times -3 is positive 6 minus 3. So we get 12. Therefore, this is positive. And we know because it's a quadratic, right? It's going to, each time, it's going to switch from positive to negative. So our next interval is going to be negative, and then the next interval is going to be positive, right? We know that by, if we look back at this graph, right? So what we can do is we can either solve by trying our first one, right? So if this was negative, the middle one would be positive, and this next one would be negative, right? Or we can look at our A, and we're going to know that if our A is positive, right, then we're going to have concave up, and we can look at the graph over here. So either way works, right? But if you do it this way, remember, they alternate from negative to positive, okay? So our solution is positive for x is less than -1 and x is greater than 3. And here is our solution, okay? So I showed you two ways. Either way will be fine, right? But you need a factor first, and then you just need to look at the intervals and tell me whether they're positive or negative. So I want you to try this one on your own, and then what we'll do is we'll go through the solution. All right, so if you factor this, you get x plus 3 and x minus 7. So our solution is x equals -3 and 7. So we need to look at less than -3, between -3 and 7, and greater than 7. I actually tested all 3 points, but really you only need to test one because we know it's going to alternate. All right, and this one asks when it's negative, so it's negative here. Right, and if you think about it, and if you want to use the graph to view it, right, here's our x-axis. It's concave up because a equals 1, so concave up, right? And this is -3. This is 7, right? So we can see it's positive anything to the right of 7, anything to the left of -3, and then it's negative between them. Okay, so you can use the graph of it to help you, or you can test the intervals, whatever one works for you.